All right. Hello, good morning, good evening, good afternoon. My name is Mr. Hill. This is eighth grade science. And there we go. All right. We're going to do a review of kinetic molecular theory. And tomorrow I will talk about how this directly applies to solutions that we've been dealing with, and even solubility, because there's been some confusion. And I want to bring clarity to this so that way we're not moving in a direction that's working against us. All right, kinetic molecular theory, or KMT. Scary name, but it's not scary. It just means motion, kinetic. All right, and that is a semi truck moving on the icy road. That would be scary. And you got some guy look like he's going to class, doesn't want to be. I guess this must be a test for him on the day. Who knows? All right, but again, means motion, energy. Quite often, you may have been taught that kinetic energy is energy that an object may have because of its motion. Well, solids, liquids, and gases do have kinetic energy in it on a level that is both atomic, subatomic, meaning inside the nucleus of the atom, but also what they call intermolecular. That means that between molecules, there are energies, if you will, or forces. And we know these things as bonds, B O N D. And you have different types of bonds, and these bonds are bonding come together. And what they also do, they hold things together in the sense of forces and things put together at play. So, with that being said, we may not see them with the naked eye, but in solids, liquids, and gases, those bonds exist as part of molecular theory. Particles and solids, in particular, if you will, everything is put together, tightly packaged. It has no kinetic energy in terms of the solid itself moving around. But on the inside, there are a lot of forces that's bonding it strongly together, keeping it from where one particle or even one molecule moving away from each other. It's a very strong bond. And we recognize the structure, which is like a very much a lattice structure or the lattice structure of ionic compound, even metallic compound right here. Liquids are made up of atoms as well, and they're more like neighbors because they move around one another, they slide around one another. They're not necessarily a gas and not a solid unless they're frozen, but they move around and they have more kinetic energy. And gases have a large amount of kinetic energy because they move away from one another. They go in every direction that they can feel, as far as a container. So solids, tightly packed, liquid, some kinetic energy, and then gases have a lot of it. But the thing with solids is that we're talking about the object itself as one entire compound moving around, if you will, not necessarily today the forces in between them. But solids have low kinetic energy, liquids some, and gases high amounts. The model itself was actually based on the motion of gas molecules, and which we know is rapid, constant, and random. States of matter, state of a matter of substance depends on three things: chemical identity, temperature, also the pressure itself. So chemical identity matters because different substances have different melting, freezing, and boiling points. And think about this right now. We'll talk about this tomorrow, but think about this now. Think about how these things affect solubility. Solubility is all about how well sol- um, a solute dissolves in a solvent. So if we look at those things for what they are, we can really consider how this kinetic molecular theory really applies things. Just think about that today. For example, O2 oxygen has a very low boiling point and is a gas at room temperature. Salt has a very high melting point, but it is a solid at room temperature. Why? In order to investigate three phases, we're going to have to establish some rules, especially to gases, write them down, uh, red definitions. You don't have to write down the red definitions, but if you want to write down definitions, you can, and take them in notes as needed. So let's look at this further. Gases consist of small particles that are far apart relative to their size. Gas particles also are teeny tiny particles you don't see on the screen are huge. If gas particles were on the screen, it'd be a size of like a marble right here. Also, gas particles have constant random motion moving and are consistently colliding with each other and within the walls of the container. That's something we realized before about how that creates a scattering and of how energy is released and how things are part of what we consider to be chemical reactions as before. We talked about that 2 or 3 weeks ago, I think. But we do recognize that from before about collisions and colliding, if you will, things bombarding. And that in itself involves energy. And that's how energy is transferred in itself. And think about electrolysis, for example. If you put salt in water and the water starts to dissolve the salt, if you will, and then break apart the ions make up the salt and it's able to conduct electricity because the electrons are free enough to move around to carry the signal or the flow of electrons from one ion to another. Like bouncy balls, they never loses their energy, or actually 3-year-olds at a birthday party as well. That's what gas particles is like when constant motion. Also, the collision between other gas particles in a container are called elastic. What that means is that it will occur where the same amount of force that is used to collide will be the same amount of force to push both people back. So if you see the two people wearing the uh, bouncy ball suit, if you will, when they jump and try to belly flop each other, belly bump each other, they're going to bounce back with the same amount of force that they were used to collide together. And that's another concept called the law of conservation of energy and also the law of conservation of momentum. They both come into play with things like that, and we'll talk about that another time. But that's what's going on here. That's what it means by elastic. Or you think about what is called a paddle ball. And the paddle ball was a ball that had a bouncy rubber ball on it. And between the ball and the paddle was a string or a rubber band. And what you do is you bounce it. And when it bounces off the wood paddle and out into the air, it will only go the length of the string and then will come right back. And that's called an elastic collision, if you will. All right. So we've covered the first three. Now, the fourth one is this: there are no forces or attractions or repulsions between gas particles. And like water bonds together, remember that there's surface tensions, my fault, not surface temperature. And water likes to bead up and bond. Gas particles, they don't care. So, like the picture says, um, honey danger, don't care. Gas particles just do not care. Most important rule of all, that the average kinetic energy depends on the temperature. And it's really important for everything we're talking about here. This is just a review of kinetic molecular theory, as we talked about before. Your temperature is going to affect how fast things move and don't move. Think about the human body. When you're playing sports or you playing a game, your body starts to warm up. You're playing basketball, football, hockey, field hockey, badminton, rugby. Your body starts to warm up because the processes start to speed up, and the more it starts to speed up in your body, the more your senses and more your ability are able to be heightened to play that game. Now, the kinetic energy inside of a liquid, solid, or even a gas is going to help it be able to interact. So in our case of solubility, which we'll talk about again tomorrow more in depth, things can dissolve faster in hot water than they would in cool water because, well, you have things exciting going on in the water to help it operate. If you look at here at the effective temperature, what they call molecular velocity, which means the speed and also the direction in which the molecules move once heated up. And so if you look at this here, this is dealing with a liquid with some particles. And now over time, as temperature heats up, you can see that these things start to change under the guise of the temperature. and the interactions start to behave and move faster and faster. And basically, as you go up higher and higher, you'll see that. Think about boiling water. You might see bubbles in the water start to form faster and faster as the temperature of the water increases. All right, so absolute temperature is something that's measured in Kelvin. This is a part of the scientific notation dealing with temperatures and kinetic temperatures in itself. Usually, we use kelvins or Celsius in science. So, no degree, symbol, nothing like that. Just to convert it, you add basically 273 to Celsius. And then if you want to go from Celsius to Kelvin, you subtract 273. So the phases are states of matter. You have solid, liquids, and gases. And you can have a gas cool down to a liquid, which is called condensation. You can have a liquid cool down to become a solid, which is called freezing. And a solid can become a gas, which is called sublimation. So fireworks, we see it every year. Do not play with fireworks without the supervision of an adult. I repeat, no playing with fireworks without the supervision of an adult. Solids, like the fireworks, when it's lit, it will go from being a solid as a powder into gas. So it skips over the liquid phase, which uses a lot of energy to make that happen. Makes that big boom sound. And the more it happens, or the faster it happens, the louder the fireworks are. And you can also have it go where a gas goes to a solid, which is deposition, like deposits, if you will, solid to a liquid, which is called melting, and then liquid to a gas, which is called evaporation. When things heat up, water boils too long, it'll evaporate. All right, here's a class work. Must be done in class. Not if you take it home, or you basically do it by the time it's be done and due. There's a lab activity one, lab activity two, and the three matter phases assignments. There's an extra credit activity that would be as a quiz on Friday the 11th. Have any questions? Please do contact me. Thank you for watching.